This is experiment 1 of grade 10 Technical Sciences. This experiment is on page 67 of your Technical Sciences textbook and workbook. Our aim is to measure the average velocity of a laboratory trolley with varying initial velocities. Our investigative question is, how will the average velocity of a laboratory trolley vary with varying initial velocities? Our hypothesis is, the greater the initial velocity, the greater the average velocity. Our variables are: the independent variable which is changed is the initial velocity, or how hard the trolley is pushed. The dependent variable which is measured is the average velocity, and the control variables which remain the same are the trolley, the mass, the frequency or period, and the gradient of the track. The apparatus that you are going to need are the following: a trolley, a track, ticker tape, and a ticker timer.
The method is as follows. Place the trolley on a track and lift up one end of the track very slightly to compensate for the friction of the wheels of the trolley. Attach a ticker tape to the trolley and thread it through a ticker timer that has a frequency of 50 Hz. Switch the ticker timer on and give the trolley a light push to start the movement. Tear off the start and end of the ticks on the tape. Keep the middle quantity of ticks where the spaces are fairly equally distributed. Repeat the experiment, but this time push the trolley slightly harder. Mark the tapes as experiment 1 and experiment 2. Use a frequency of 50 Hz for the ticker timer and calculate the period. We use the formula T is equal to 1 over F, which is equal to 1 over 50, and this is equal to 0,02 seconds. The time for an interval of 10 ticks is as follows. One tick takes 0,02 seconds. An interval of 10 ticks is then equal to 10 times 0,02, which is equal to 0,2 seconds. The time for 5 intervals is then 0,2 times 5, which is 1 second. Divide the tapes into intervals of 10 ticks. Mark the dots of tape 1 as A1, B1, C1, etc. Do the same for the other tape. Complete the following table and determine the average velocity for each repetition. For experiment number 1, the distance for AC is equal to 0,274. The distance for DF was 0,268. The total distance for AF was 0,675. The velocity for AC is then equal to 0,274 divided by 0,4, which is equal to 0,685. The velocity for DF was 0,268 divided by 0,4, which is equal to 0,67. The average velocity for the total distance is then 0,675 divided by 1, which is equal to 0,675. Complete the table and calculate the average velocity of each motion.
Our conclusion is, the greater the initial velocity, the greater the velocity for each corresponding interval, for example VAC. When the initial velocity is greater, the average velocity for the same trolley and mass will be greater as well. The intervals of tape 1 are all equal in length, but shorter than the intervals of tape 2, of which all the intervals are also equal in length.